start with the modern concurrency as we discussed. So first of all, the need, let's see like why we needed modern concurrency. Like were the dispatch queues or the operation queues were not self-sufficient enough, like we came to the task and this async await concept. So let's discuss about this first and then let's go over to the modern concurrency topic. So as you know, like in the dispatch groups, we have the dispatch groups and the dispatch queues. So the point is like here you are creating your own, like you have to create the threads, you are creating your own background threads. So the point is like we know like we are at the end of the day humans, so sometimes we might end up like we have like, let's say we are in the main asynchronous calls, and in this main asynchronous calls what we tend up, we might again call the main thread, and this main thread now we are making it sync type. So we might end up like thread explosion, you know. So what happens like sometimes if what we'll be doing, we would be from the main thread, we are making it asynchronous and then we are making it sync. So this will lead to a thread explosion. But if we go with this global thread, and from the global thread if we want to go for any main task, we can go ahead in a simple manner. But when we are making our own threads and OS is not responsible for making these threads, so there could be thread explosion or the app might crash. If I say in the layman terms, the app might crash. So this is a very important thing. Is there some trouble, Arjun? Yes, from my end, I have turned on the recording in the quick time. Okay, no worries. So what I was talking, like we have to maintain these threads. We have to make sure like there is the OS stack is not full with the threads. Like we are just overloading our own threads that we are creating. Our the global threads in the from the thread pool that we are taking, we have to make them they are free also. So there would be a ample of things that a developer has to take care of. So it's better like when we are progressing and when Swift is giving us the chance of the this entire headache of making the threads and releasing them could be covered with the task and could be covered with the modern concurrency, then why don't you just lease your works ahead? Like we can focus on many other good UIs, or we can create some more better product rather than taking care of these threads. So that's why we have the modern concurrency. So this is a main advantage. Here in the modern concurrency, the operating system is taking care which thread they have to provide us for the background operations, which thread they have to provide us for the operations that are taking place in the UI. So we do not, we just ask the operating system, hey, do you have a thread, I need it for a background operation. So operating system will give me, and once my work is done, operating system will automatically take care, like we are releasing that thread again to the thread pool. So we are not concerned about this headache. So this is the basic concept, like why do we need or why we should shift towards modern concurrency. So now I will give you a glimpse like how things work in modern concurrency. So when we are talking, so first of all, let's say I have any function. Let's say this is a function to download any image. Okay, so download. Sorry for the bad handwriting. To we have a download image function. Okay, so we first have some basic format or the syntax that we have to follow. Here we have the async keyword that denotes like this function will take time, or this function is asynchronous in nature. This will tell us like, or the operating system or to the user, like this function would be in asynchronous in nature. And if we want, like we know, like we have a API called the API might fail, so we can put it here as the throws keyword, which will indicate like we might go into errors also, we might have any errors during the fetching of this. So this is the basic syntax that we have for the any asynchronous calls that we make. Okay, and here whenever we want like actual function, let's say here I am calling the API, I have my URL request, and here I would be creating my entire URL request and I would be making my API call. So here I would make await. This is the main, like the skeleton of this entire concept. This await will make sure like my things are being taken care by the operating system. My operating system will allocate me a thread that will go to the background, and this thread will make sure like it will make all the work that is being requested to be done here, and then we will be coming back. So let's have an entire like working, like how things are working. So I will just give you a basic like diagram view so that we have an entire concept clear. Okay, So here, let's say I have my, so here I am calling, let's say I have my function that is, we can say fetch image. Okay, so here is my basic function that has been called. Okay, my fetch image is having, as I told you, we will have an await keyword in the line that will be exactly doing the work that would be going for that particular data request or the call. So here I say this is my data request. Okay, and then here is my operating system. So let's say here is my operating system that is been lying beneath. Okay, so you can say the system in the layman terms. So then this is basically my request that will be again being called. So I will just draw the diagram and then I will give you an entire walkthrough how the things are working. And here we will again have this fetch image. So what's going behind the scene, let's see it. So what is happening when I have this fetch function that is being called? So what happens, it will first execute in this main thread only, because from the view only you would be calling this function, or from the view model you would be calling this function. This would be in the main thread. So then it would be in the main thread when it will trigger this line, when the compiler would come to this line await, and let's say there is a data request url session.data.task, that we have a data request that we have to perform this particular like in download this image, let's say. Okay, and then I have another line, let's say for the time being I'm not doing anything. Let's say we will just print that image in the console. Okay, so just a simple walkthrough of things working. So here I'm just doing this thing. So what will happen, this would be first basically, let's say step A, this would be my step B. So here my things would be running in the main thread. Okay, they would be, or in any thread, like if let's say we were from the background thread, from the background thread only we are coming to the another thread. For the time being, let's say I have a button and I click, I will go to this function. So let's say that button was on the main thread. So this was on the UI thread, the main thread. So then we came to this data, this function, and then we came to this line. At this line, we will see there is a wait keyword. This will say what? It will say to the operating system, hey, I need one thread from you. Operating system will say, okay, what kind of a thread? As it will see, it is an await kind. So we mean like we have to go for any background task. So any background task, it will take one thread. It will ask, hey, do you have any thread available? At this time, you cannot be 100% confirmed like operating system will give you like it is free and it will say, hey, take this thread, I have this thread. No, this is not guaranteed. Might be operating system would be having some other priority task that has to be done in the parallel, like let's say there would be some other app that would be using its background thread. So operating system will say wait for, let's say 5 minutes. So let's say 5 minutes we have to wait. So here we will be waiting. So this another line, let's say this is line number 1 and this is line number 2. This line won't be executed. We are in a hold state. So we would be waiting for the operating system to give me the thread. Let's say at some point of time operating system was generous enough and it gave me a thread, and let's say that thread name was ABC. Okay, so this is a thread name that operating system gave me. It said, okay, now you do this work. So when I'm doing this work, there is also not guarantee like when I'm like, let's say my image downloading will take around 10 minutes, or it is not an image, let's say it is some big file, a zip file that we have to download. So this is taking 10 minutes. So might be operating system at that particular time I would have done like 30% of my downloading work, and that particular time operating system came and it said, hey, give me your back ABC thread, I have some very particular important task that is of priority 1, P1 priority, and I have to allocate the thread. So then again my thread, this is gone. Okay, so again I have to stop this work, like I have to put this work on hold, and then operating system will take this thread back from me. Okay, so let's say now ABC thread is gone for P1 task that it got. So now what will happen? Again, let's say I have a task. Okay, now operating system was thinking, okay, it has some, this task will take time. So operating, it is now not guaranteed. Like you would be thinking like ABC would be again this thread only we will be getting back because it has done 30% of the work. No. So again we might get a thread that is, let's say XZ. So this thread now operating system saw this is free in the memory pool, we can give this thread back to this data request that we have. So now operating system gave me this thread, hey, take this XZ, this is free, ABC I won't be able to give. So now XZ will continue this, resume this entire work that we have left. Okay, and once this is done, operating system will see, okay, this is work is done. When it is 100% done, task is complete, it will take this thread, it will now put it in the memory pool or the thread pool that we have again, and then we are done. So once we have this data, we have the things that are being completely done and the threads being free from the memory, then again we will go back and resume to the next line of the function that was after await. So let's say I have another line that was printing that thing that we have downloaded. For the time being, as I said, it was an image. So then we will be again back to this function and we will start the execution that was after this line. So in this you have to take care, like whatever things that are written after await will be executed once and after this function is completely 100% done. Okay, so this is how a basic working of await, async await works. So if you have now the work that has to be done in the main thread, this is another point that we have to take care. So just a second, let me zoom out my screen. So here we are. Okay, so here let's say we have the main thread, and this main thread, um, let me go back to a new page. So here what was happening, like we have the things that were going in the background and these things were going in the background and they were running. So now what will be happening, we have the function that was the fetch image, so it was coming back from the, as we know, operating system background thread. So now you want like these UI updates, you have a button here and this UI update should happen on the main thread. Basically every UI things will happen on the main thread, that is pretty obvious. So what we have to do here in this, we have something known as task. So this is kind of a closure. So what task gives us is a facility. Like here, let's say this was my async kind of a function. As I told you, we were telling like this is my async kind of a function. So here from the task, what I can do, I will have the facility to call this function. So how I can call this function? So I will make sure from this task, I will call this function. So here was my UI that I was been creating in the, let's say there was where body and it was kind of some view. So this is a basic syntax that we write, some view and all. So here from the I am from this main thread, I was executing my things in the main thread because I was making my UI in the main thread. Now in between, if I have to go back to the background thread, so this advantage is given by task. So I can make a task closure, and within the task closure I can make this async, okay, this async call, and in order to make that I can just write this await. So I will write here await. This will denote like, okay, so here the compiler will know, okay, now you are switching the thread, so it will allocate you a background thread as soon as in this function it will counter the is await function. So this is how things are working. So this task will help you to switch between the threads from main thread to the background thread and from the background thread back to the main thread. This is how your things are been working in place. So that's what's a basic like things, like this is your async await that things are going on. And if I suggest, like when there are API calls in the task also, you should make your functions like in a in do catch blocks, so that your things are not ending up in a crash, so that you have any errors. Like let's say your API call was failing, so here what you can do, you can just show a alert view in swiftui or somewhere, like any, if you're using UIKit, it's up to you, like a alert view like, hey, there was some error, and the error whatever you want to take place. So as we know, like in the dispatch queue.global we were using, here we can use task in order to take the threads on the background. Now the point is, okay, I am doing my async calls, everything is working. How can I make sure like there are no data races? This is important because let's say here I was having one image that has to be downloaded. Let's say I have 10 images to be downloaded. Okay, or let's say I have a database where I have to write these 10 images. I have to make sure like there is no overwriting or there is no data race condition. So here also in the modern concurrent, like in this we were having the facility of locks. So here we also have the same concept. We would be using the logs, but in a different manner. Here we do not have to care, like we do not have to take care, like we have to the log being captured and we have to release the log. This also the things manually that we were doing previously are being taken care by some great things that are known as actors. So I hope this much concept is clear, like how async and await works. If you can guys give me a thumbs up, that would be great. Questions we can take it later. So I think this much we are good. So we can go ahead with the actors concept and then we will go with the practical examples. So let's start with basic things like why do we need actors and what were they required for. So basically, let's as I was telling you, we might like let's say we have a bank application and that is a simple example that we used to take in our engineering classes also, and there is a bank and here is my balance. So where we have your balance here that is to be written, so we have to make sure like the balance is appropriate. So let's say here I am creating like 10 API calls. Okay, and these 10 API calls are let's say of read and write both. And if I go there directly, this will create a database. As well as, see, there are two things. One is data race, another is race condition. Okay, so race condition means basically we do not know which line executed first. Like we wanted like line, this was one API call of let's say first read to read the balance, and that was another line that was to write the balance. In an asynchronous environment, there might be any chances like what happened instead of this line 1 executing at first place and this line 2 executing at second place, race condition happened and somehow line number 2 got executed first and this line did not execute. So what happened, let's say if I had a balance of 10 rupees in my account, so what happened like I want to withdraw let's say 1000 rupees, and then if I did not read the balance first and then directly write, so I it would be a minus 900. So we this is called race condition. Okay, so now we have a date. What is then data race? Like these are the questions that could be asked in the interviews. So just giving a quick glimpse over this. So now what is data race? Data race is basically now you were told like let's say you had a balance of 100, so this is basically data race also. Why? Because your lines got executed in a manner that led to a dirty write on your on your balance. So this could happen. So these things we have to make sure, like in UI kit we were using logs, or in the previous Swift UI in Swift, so here we have the facility that are known as actors. So what actors will do, actors are also the same category. So these actors will make sure whatever data you have here, whatever like properties or attributes you have, they will run in synchronous manner only. Okay, they will not make they will make sure like your are not having these data race and race conditions, so there won't be any dirty read or write. This will help your basic database to be stored and preserve its properties of atomicity. So what will happen like now, if you have an actor and let's say if you are having 10 calls or 100 calls of API to download or to make any changes in the balance, now actor will make sure every API will only enter, or like let's say as we know we will have one log, and that log will be given to every API call that will make the read and write operations. Once that API call has done its work, then actor will be free for any other available API that wants to read or write the operation. So basically actor will make sure like only one time one person is accessing my property so that I do not went into database conditions. So this is how basic actors work. So and when you are using task and all, so what we can do when we are, let's say I had an we have a class. Okay, so let's say we had a class, let's say this is called testing class, and where we had to write something. So and here are my properties. Let's say I was having a struct type property and that was a balance, so let's take it a balance only. So where we are having a balance. Okay, and if I make it as of, let's say it was having some properties and reference properties and it was of class type. So here is my balance class. So here if I have to run into an, let's say I was running into many asynchronous like in dispatch queue, and in concurrency I made 10 calls. So what will happen? Every thread will go and make sure like it is getting its work done. But if I make sure like there is a task, okay, and here if I make it await and I make it this as actor. Okay, so here the difference is like you will have instead of word written class, you will make a class as instead of class a balance. So here you will have your work. So you will make sure like your await is done, because whenever you are accessing the actors functions or variables, anything that you are and that is leading to any write conditions, they will be always of asynchronous types. Why in the asynchronous? Why? Because we know like this will take time, because if I have 10 or multiple API calls, my actor will allow only one at a time, so others have to wait. So when others have to wait, we have to make sure like it is of await, and this would be basically every time asynchronous by default. So this will also run in multi-threading environment. So this is basic actors. So now I will show first basic examples like how we have to go with this, and then we will see like some points where actors might also go into data race condition, and then how we use another approach using actors only to make sure like actors are not being accessed by multiple environments, and then we do not have any data race conditions. So let's go ahead with the some basic examples I will show you. I hope my Xcode playground is also visible to you guys. Great, thank you. So what I have done, as I told you, there was one basic bank. Okay, so this is a balance that we have to write. Okay, and this is basic init that we are doing, and I have to make a transfer. Okay, so there is one basic transfer that I am doing of 100. So basically first I have given them initial values, you have your 100 rupees each. Okay, and when I have to transfer, what I'm doing, I'm making this as asynchronous call. Why as asynchronous? As I told you, because if multiple people are reading and writing this operation, we have the actors capability that it will make sure like there is no data write conditions. In order to prevent those data write conditions, I have to make this asynchronous. Why? Because we have others API, they have to wait. So until and unless I have this deposit work being done. So deposit is what I'm just entering the amount. Simple. And this I'm doing in my simple balance variable. Simple. Nothing fancy over here. So what I'm doing when I'm writing these things, I have to make sure like there is no data race. So first of all, I checked like whatever the amount that the user has to transfer, is it greater than the balance? So then we are just returning false, else I'm just removing that amount. Okay, and then I have to transfer it to the another account. I'm doing that deposit. So from this account. So this is simple thing that has to be done. So what I did, first of all, I made this actor so that everything that are being doing the read and write operations are inside the actors. Okay, so as you see, this is the write conditions that have been taken place, and this is the read conditions that have been taken place. I did it inside the actors in order to make sure there is no database. So now we have a class. Okay, so this sendable I will talk to you later in next 15 minutes. Just ignore this sendable for time being. So what I'm doing now, I have this asynchronous call, and from my actor, I'm calling this. So I am making one base actor, this my class action instance, and this instance I'm just transferring 70 rupees from bank account number 1 to bank account number 2. Okay, and then another call I'm doing, I'm making 50 rupees transfer from bank account 1 to bank account 2. Okay, so this is, and then see, these are my two asynchronous calls. This is a syntax that we write. If this would have been a basic UI, then we have to go into the background thread. So for going into the background thread, we use task. And then I just make sure like I have to wait for all my API calls that have to be called, so that I get the entire result. Like I have said this, okay, this is my API call async let, and then it will be done. And this is my await. Why I have used await, as I told you, because these actors are my basic asynchronous type. In running in the asynchronous type environment, we have to make sure like when we are getting the values, we are getting the exact values, and when we access them, we have to make sure like no other thread is accessing their properties. So we made sure like await, when we get the chance to read the property, when no one is reading and writing, then we are getting this call. And then in the similar fashion, I call for the bank accounts balance too. So let's run them. And as you see, the first bank account, it was having 100 and I had to transfer, it was 30 rupees gone. And then I made a call to this second one, and then it was second one that was being called, and then these are the properties. So I made sure there is no read or write any conditions that were coming. So this is basic async let. Okay, so async let, and there is one more, async await. So I will tell you the difference in upcoming 5 minutes. So this is a basic like I have given you a thing like how this is a structure, like you have your actors been working. Okay, so one more thing I want to show you guys is an example of like how we can make a task and await. This is await. We can have, like, let's say, as I told you, can have multiple calls, asynchronous calls. So how we can make those asynchronous calls? For that we have task group. So what task group is basically doing, we are making one group of that could be asynchronous type. Since it is of asynchronous type, we know, and we have to wait for its completion. Now in this group, what I am doing, I have to add multiple tasks, like I have to make multiple calls. In order to make those multiple calls, what we can use, we can now keep adding those multiple calls. So these add tasks means like these all are running in asynchronous environment. So if I say how asynchronous means, yeah, here is my group, and in this group I am making one call, this is another parallel call that is going, this is another parallel call. So there are 1,000 calls that I am making, like triple line calls. So these triple line calls are going in parallel. So how I am able to achieve, using this group, I just made one task group, and this group I am adding each task. So every this call is going in a concurrent manner, and once it is finishing, they are coming back and telling, hey, we have done our work. And here I have made a wait for all the tasks to be completed. Like if you do not want, you can remove this line, like do not want every task to be completed, else you can have a wait. It is better to wait for every task to be completed, so that you know like there is no error in any of the API call, so that you do not have any like you in UI you have to show like if you have many API calls, and if any of them one fails and it was a right condition, you have to make sure like it is failing. So you have to wait for that call, and once it fails, you show it in the alert view or in a toast message or any form like XYZ failed. So this is a basic thing. So using task, you have this facility to make asynchronous calls. So that is a best advantage. Now you do not have to make, the point is, if you would have been using dispatch groups and all, we have to manage the threads. Here we do not care. It is OS that is allowing us, it is OS that is taking care. So we are away from these situations. So what I'm doing, I'm making these calls. So as you know, I have made triple line calls, and in order to make sure like they are in the let me just clean my drawings. Okay, so in order to make sure like these are done, I have what, there is a way we can sleep our task. As you know, this we were doing, whatever task we have, we can, I am making it a sleep of 2 seconds in order to just indicate there was an API call that was happening, just to give a visual example. So let's say this is my API call that has been happening, and then after that I'm increasing my balance to 1 rupees, simple, and then I'm returning my balance. So here what will happen, there are many threads that are trying to access my database. Great. Okay, so with this I'm able to achieve this. Now the point is, let's say in the actors, if I have a static variable or a static function, then what do you think? Like we are having a actor. I told you like actors will not have any database conditions because they will take care. But what if I make the I'm using this entire actor instance and sending it to one thread, and this thread is also making its new instance and then sending it to its thread. So here we are in a conflict. Okay, so this is a conflict because if we are using the same instance of this actor, let's say obj, and this instance is if every task is using, then it is well and good, then we do not care, like we are officially, we do not know like there would be any data race conditions, let's say. Okay, but if we are using one instance and we are passing it to triple line threads, and let's say we have this one instance and every thread is making its own instance triple line instances are being made. Then what do you think? Which will enter into data race? Any guesses? Okay, I take it as a no. So the point is we will get into a data race because the we are making instances of this actor. So what is the use of then using a actor? We have to make sure like we are using only one instance of this actor and then passing it throughout the application for every other API call to use it. Because if we are making every actor's instance and passing it, there is like, what is the use of making actor when we are making instance of actor and every new instance is being passed? Just try to get this point. So let me just remove this and stop this annotation. So here, let's see. As I was telling you, I did not make a static instance of this. Okay, this was my base actor as I made, and I was just making a perform basic updation to my bank balance. When I make this, what I was doing, I was making every this basic simple actor, uh, and it was reading the values. Okay, so actor was reading the values. Perfect. Now let's run this and see, and I can show there would be data race. As you saw like there was so many conditions like triple nine were there, and we get the value as 986. So there is a difference of values. Okay, so why this value difference occurred? Because every thread was accessing, so every time we are getting different values. Why we are getting? Because the threads are making their own instances and they are going to the actor and they are reading their values. So this was a static function, so it did not care of making an instance, and it ran to the actor class and it made the changes. So this is also not a good case. So how to get rid of this? Let me show you. So let's first clean this board and then, okay, so as you saw, first of all, we can make multiple calls using task group. Very simple, quick and easy thing. And once we have this task group that is making multiple calls, now we will see like what to do in order to make sure like actors also do not go into the race conditions. For this, we have one great thing that is known as at the rate global actor. So this is a global actor, and if I confirm to this global actor, it will shout to me. Why? As I told you, like now global actor will make sure you have only single instance of this base actor or this actor class available to the entire application, so that you are not running into these kind of database conditions. Okay, as you can see, it will sing it is not conforming to the global actor. Okay, let's fix. In order to fix it, now I will make a instance of it. So now what I'm doing, I'm making this instance and now I will call this shared instance. Okay, and now let's avoid this. As a best practice, we have to make sure these are not static, and here I am shared. And here also we have to make it shared. Okay, and why it is okay, so here we have to remove this, and we have to make it. So here also let's see. Now you saw like there was 1,000 calls and we are able to fetch those 1,000 calls. Got it? So this is the thing that we have to make sure. Like these are some best practices we have to make sure, like in order when we are using the actor, we entire application we should use that single instance only of that actor. Else again we are back into the data race conditions that we are trying to avoid as a developer. So this is the basic thing. So what I did, I made everything as simple private as the main thing, that is the balance. We have to make the private, and then I used remove the static things, and it was very easy to do the things now. There is another way, like you say there are hundreds of actors in your class because you have many write conditions, or let's say 5 6 actors you have. So you can use this manner, like inside that actor only you can make it and confirm it to the global actor. That is also a good practice. Else we have one more thing I can show you, way of doing this. Simple. I have just copied that code at the top only and I have showed you in a different flavor. I will show you in a different flavor. This was my actor. Simple. That was reading the data and it was printing the data. Okay, nothing fancy over here. So now, since I told you there would be many actors in the class and I have to make it sure like every is using one single instance, so I can make one single class that will hold every actor's instance, and I can make that class as final and global, so that we do not have any data race condition. Now this base global actor class is holding my shared instance of my actors. So if we have many actors, then all the actors instance we can add over here. So this is like the entry point of every actor class. This is also a better approach you can do, or in the either way, if you have only 1 or 2 actors, then you can use the bottom this approach, like putting directly into this static shared instance into the global actor directly, it can confirm. So these are the two ways you can perform your things. Okay, so now the question is another that you can ask, like read and write values are inside the actor, this is also inside the actor, and but you made this as a class. Don't you think this would also be sometime might run into conditions? No. Why? I have made this as final, and there is one more thing that is known as sendable protocol. See, sendable protocol, if you are using in Swift 5 or 5.10, 5.11, you might do not get any like warnings. But if you're using Swift 6, from Swift 6 onwards, you have to make sure like if you are having some work that is done in an asynchronous environment and that having could be reading to any data conditions, we are having read write operations, we have to make sure like if we are using classes, we have to make sure like they are conforming to the sendable protocol, else Swift UI will shout on you. Why? Or any Swift like UI kit and everyone, they will shout on you like, hey, this is an asynchronous environment and this do not conform to the concurrency. So you have to make sure this is a sendable protocol. In order to have a sendable protocol being implemented, you have to make sure your class is final, as I have done, and all your variables are immutable. So this is where, and if I just make it where, you will see my compiler will shout. As you can see, it is not concurrency safe because it is non isolated. That was a simple thing. Okay, so here are the things. So here you can have all your instances of your actors. So if you're using Swift 6, you have to make sure like it is conforming to the sendable protocol, else your system will make sure you will have your compile time errors. So this is the basic thing. Like this is how you are using global actors, actors, sendable. Now you will say you are making sendable conforming to the class. What in case of structures? So structures and all the primitive type values that we have, they are by default conforming to the sendable protocol. But since class is a reference type and it may be shared by different objects, or the reference could be shared by different objects, we have to manually make sure like it is thread safe. So in order to make sure like it is thread safe, we have to make sure like it is conforming to the sendable protocol. So here I can give you one more example, like how to, let's say I have a class, I can give it test, and if I'm conforming to sendable protocol, so it will cry. Why? Because it is non-finable. So we have to make sure like the class is final, it is not having any mutable attributes. So these things will make sure like we are conforming to the sendable protocol. So one more, I have an example for you. I was last night making a small app for myself. I can show that like how I integrated the sendable protocol for that also, and that I wrote in Swift 6. So this is a basic example. I will show you like how the APIs are working and how we can make sure like we are using the latest Swift 6 as well as we are using task. Okay. So I will just show you like I'm using Swift 6. Let me just move this screen back. Where is it? Okay. Mm, I was um, there was somewhere I made the change. 1 second, it was there last. Here it is. Swift language. We are using Swift 6. So let's see how things are working here. So we will have a small example as well, like in real world how we have to use async await. Okay, so first let me run the app for you guys so that you know. Let me just turn on the VPN. I do not know with my Geo network it does not allow this API to work. Mm, and just a second. Great. So let's. Okay, it is running in my device. 1 minute. So so this is the basic app that we are running, and this is the we are making just basic API calls for the environment that is asynchronous, and it will have these images that we are popping up. So, okay, so this is the basic app. I was yet to implement the entire UI. So at last night I made this. So let's see how it is working in the modern Swift concepts. So what we have, where is it? Here, as you can see, this is my basic entire UI that I am been creating. Okay. And then when I had to go into the asynchronous environment, I made sure like here in this task, I first showed my loader, and then I wrote await, and here I am going in my view model to fetch my data. So here till this line has not been executed, we saw the loader, and once that line was executed, we got whatever we had to fetch. We are making the loader as false. So this was very easy. So when you know you have to make this line is executing, the loader would be true on the screen, and when this line is done, the loader will go away. Okay, and I had like if we are having any error, so we will show the error view, a simple small thing that is done. Okay, so now let's go into this, the main thing. So you can see this was my observable, because I have to make sure like the when the data is there, we have to put the data into the screen. I had to make sure like my things after they are done are going back into the main actor. So what this main actor does, it is like the basic actors that we were using, global actors and all. This main actor makes sure like when the things are done, it goes back to the main UI or the UI thread, in order to make sure like once these things are done, after they are coming, the next line that is being executed, they will go back to the main thread. This is done by main actor. Now in this what we are doing, try, and then we are making this network call. So we know like this would be the main network call. So this was a basic JSON that is being decoded, and then we are using these basic JSON calls that we are doing. So in this basic JSON calls also, you just have a glimpse like we are making a try await. Okay, and this try await I'm doing in a do catch block. So if there are any errors, we will throw them. So here my line will execute, it will pause, we will have the exchange of the threads in the operating system, and whatever we got, we will be in the background thread till here. And once we are back, after this line, whatever would be executed in the next line, we will be making sure like it has been executed in the main actor. The main actor will make sure it is going back to the main thread. So this is a basic example that we did to show like how things are working. Now I made this class, and there was, when I was making it in Swift 6, I got some errors. So I can just show you how it was shouting for me here. So I had to make it Swift 6, so it asked me I have to make it shared let, and then I have to make it private, and I made sure like there is nothing that is being mutable so that it is not going for Swift 6. And then apart from this, I was making some notifications call. So it said like notifications are on the main thread, so it automatically Swift 6 checked for me in the main thread you are not using main actor. So it was again shouting on me. So what I did, I made it main actor. So these were the few things Swift 6 is very peculiar about. Like if you're doing any updates on the main, you have to make them main actor. If you're using any class, you have to make sure like there are no mutable states in that, so that when you are, let's say, conforming to any sendable protocol or anything, your things are running fine. So apart from this, I had one more thing to show to you. Is it here? So let's, this was my dictionary, and I was just making the API calls, and we were storing them in the config files. So I have to, when I was writing the code in the Swift 5, it did not care for me that this is a non-isolated environment or how we are working. But when I was in Swift 6, we have to make sure either we declare it as like it has to run in the main thread, or we will tell the compiler like, okay, I know this is thread, this might read into thread conditions, it might read into like asynchronous environment, then I am guaranteeing for it. So here non-isolated, it means like many threads will be capturing it. We have many threads like asynchronous calls, and we might be needing this values from the dictionary to catch the a base URL and everything. So I am responsible if the app crashes. So this is unchecked. Like the compiler will not check for this concurrency. Why? Because I have written this non-isolated unsafe. So in Swift 6, you have to make sure like if the compiler is giving you warnings, you have to take the guarantee like, okay, I will make sure like I am not running into any conditions that will lead to the crash of the app. So you have to guarantee these things. So this is the basic example that I wrote for this. So guys, any doubt, then I'm open to any questions, and the forum is open to you guys. Sure. So what is it basically? So see, if I go it in this screen only, so what is the main actor? Main actor is basically we are sharing the instance of the UI thread. It's of that UI thread, and we are telling on this UI thread you have to run those things. And actor is basically what we know, this is a database, and we have to make sure in this database we are not having any values that could lead to a data dirty data write. So that actors, they could run in any thread. It's up to you, you want to run them in the main thread or you want to run it in the background thread. But usually when we are doing actors, they are asynchronous, and they are run by the compiler in the background thread. Coming to the global thread, global thread is nothing, it is like we are sharing the we are having the instance of that particular class actor, we can say. And in that instance, what we are doing, let me, where is the compiler? Yeah. So we are having that instance makes sure like this is being accessible to the entire app. So what happens when this is accessible to the entire app? So every thread, we are not using, we might not use every thread that could take the instance of this and then do the data write. Then we, as I told you there, we can see we might end into conditions that are writing dirty data to us. So with this global thread, we are just doing we are nothing doing, we are doing the shared instance of them. Is it clear? Correct, correct. Global actor is just giving you the instance of that. Hi. Mm-hmm. Sure, that's the right point. I forgot to tell. That's my bad. Thank you for making me remind. So, see, async await and async late, they both are doing the same thing. It's like how you have the requirement business logic that you write. So let's say in async let, now what you are doing, I know like I have there two calls. Async let I can make it and then I am done, and here I am writing await. But let's say you have 1,000 calls, so you have to make 1,000 times async let. So that is the only main difference. When you do not know the number of calls, or your calls are dependent upon, let's say they are dynamic, let's say the user have two cars, or let's say there's a dealer that is having 1,000 cars and he want to make 50 cars update only. So when you do not know how many times your API you have to call in the background, at that particular time you can use a group. So what will happen in this group and async here you are using await. So what will happen, you do not, you can just pass this dynamic value like how many times you want to update, it will make a task, and then you are done with the work. And here you are making your await. But if you know the number of calls and that numbers of calls are very less, and you know your solid principles won't be violated, or your dry principles that are do not, don't repeat yourself. So at that particular point, you know like there is one call, why you are going into this task and all creations, at that particular time you can make this async let calls. So it's like a different flavors, you can use async let and async await, both are doing the same things. I'm sorry, I did not get, can you come back again? Actually, no, actors won't allow. You have to make like, because if you are making actors because you want thread safety, and then you are writing non-isolated unsafe. So it means why you are using actors when you have to make it unsafe. You get my point. You are contradicting the statements. Sure. Yes. Anyways would be fine for you, like if you have like multiple actors then you can go with the singleton as well. But if you want like your global actor and then you can share it to other instance, anyways would be fine. It's like I showed you both ways. So here we had at one point like we can go ahead with the one class that is storing all the instances, or either we can go like we have only one actor, so we can make it directly a global actor type and we can share its instance. Okay. Yes, that article is entirely based on this example. So if you guys have any idea, you can go ahead with the LinkedIn profile or my Medium profile. I wrote the articles there. You can have a look. I can give you the glimpse of. Mm-hmm. Correct, correct. We can go ahead. Right, right. So I did not get into depth that because it would be too much to digest for today. So, mm-hmm. Right. Mm-hmm. Mm-hmm. No. Mm-hmm. Go ahead. Mm-hmm. Correct. And that would lead to app like hang. We say like app is not responding because now our main actor is busy in downloading this image or whatever data we have. So at that particular time, if you put touch any button or anything, your app would be in a free state. Correct, absolutely. So that's why it's better not to give it. So go ahead in the background thread. For. Mm-hmm. Mm-hmm. So, as I got your question, you have an actor and there you're writing your database. Okay. And then you want that actor to be accessible entire app. So you have two options. You can make that actor only global actor by making it static instance of it. Else, if you feel like you would be requiring many other actors also, so then you can go ahead with the global actor and make that instance of it. Anyways would work fine for you. It depends upon then your business logic and your requirements how you have to run the things. If it is for only one screen, so what why you are making global actors and all. But if it's like entire throughout the app you have to pass, like here in swiftui, if I have to pass a screen router, I have to make it for entire app, router has to be there. So in that scenario making global actor would be sensible. But if you have like one only screen, make it in that actor static, that would be easy for you. No worries. I hope we are good. Yeah, sure. Hmm. Mm-hmm. Mm-hmm. Okay, so you mean you are using a task over here and that is making sure. So here you have the resume task that is going back to the main thread. So if there is a catch, you would be using the continuation here. Continuation with the. Okay. Oh, that we have to debug and see like what's going on behind the scenes. Like here I cannot like entirely tell you what would be the main reason. But yes, that approach like forcefully you can give it main dot run on the, that would be also working. But yes, it usually runs. I am using in my office also that continuation and it takes me back to the main thread without any forceful done. So there would be something missing we can debug together. Are we good to conclude or any doubts? Okay. You, it depends upon what your class is having. You can make your class as main actor if it is not having any like API calls, like too much, like the data you have. Let's say you are doing some core data operations, or you are reading from any like actor. So there, if you are using the entire class as the main actor, let's say in the actor you are having something, and you are not making that as you are not having that API call, but still in the class you have two threads that needs to access this actor. At that particular time, if you make this class as the main actor, and you are reading those values, it might lead to a app freeze. Did I make you understand? Right, right, right. So this would work. Correct, correct. Yeah, that is the point. Like in that scenario, na, what I was doing in my last project, what we did, and then this is like we are using the published properties. So we also got the warning, like it is running on the main thread, it is unsafe to do that. That is pretty obvious. We get these problems. So what I did, basically, we made one actor here, and from that actor we were calling. Like let's say this is the actor, and I made the published properties over here, like published property where let's say a abc is equals to, for the time being it is 0, and here I made let me name this actor my actor. And what I am doing now, I am making this instance of this actor, let's say obj is equals to my actor. So now you will not get any warning if you're using less than iOS 17 and all. So because now here whatever data write conditions you will do here. You will write the data and you will read the data from this functions only. And then this actor is basically is having inside its properties as published. So what it will, and when you will update it on the main thread, you will not that get these warning, like updating on the main thread may lead to data write UI conditions. That purple warning we have. No, 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 no. You do not have to do anything because actor inside it is having its published. So here any changes to its here reference, because we know when there would be any reference we would be holding to this, and this references will having these published, so it will automatically say to its publisher and the subscribers, hey, my values are changing. Dynamically it will change in the UI. You do not have to take care of it, and here you do not have to make it published. In the actors only you have made it published. That's well and more sufficient. So that purple warning of yours will go away, like at the rate publish are being used in the main thread. I also got that, so I have figured this way out. No worries. Any other questions, guys? So I take it as a no. Just one last thing, like if you find my session a little bit interesting and if you feel like I shared any knowledge, please subscribe to this channel. I make videos for Swift, Swift UI and interview questions, so you can get a chance. And DSA also I'm solving in Swift, so that we can have a good practice on the lead code as well. You can go ahead and watch the videos and do, you can ping me on LinkedIn and anywhere we can connect. So we have the servant even UIs and many more things we can learn over here. That's it from my side.